Okay, very welcome back to our module. And this time we will talk about the concept of inductors in series. So to begin with, we see that there are these two inductors named as L1 and L2. They are connected in series, or they are said to be connected in series. So if we want to calculate the net inductance of this, we would say L equivalent would be the sum of these two inductances. L equivalent will be equal to L1 plus L2. What if there are n number of inductors connected in series starting from L1, L2, Ln minus 1 up to Ln? So if there are 10 inductors connected as shown, so this would be inductor 1, 2, up to this would be 9, and this would be 10th inductor. And in this case, the net inductance or L equivalent would be the sum of all the individual inductors, that is L1 plus L2 plus up to Ln minus 1 plus Ln. Similarly, now we can talk about inductors in parallel. So when you see such configuration where two ends of all the inductors are connected to each other, for example, L1 and L2, they're both the ends of these two inductors are connected to each other. In that case, L equivalent can be calculated as, first take the 1 over L equivalent, that will be equal to 1 over L1 plus 1 over L2, and therefore L equivalent will be equal to 1 over this term. So this L equivalent will be the reciprocal of this term. What if there are n number of inductors ranging from L1, L2, Ln minus 1 up to Ln? They are all connected in parallel or shunt with each other. In that case, how to calculate L equivalent? So we can write again, we can write 1 over L equivalent will be equal to 1 over L1 plus 1 over L2 up to plus 1 over Ln minus 1 plus 1 over Ln. So therefore, L equivalent will be 1 over this term. So we are basically calculating L equivalent by taking the reciprocal of this term. Now let us have few examples with the real world values of the inductors. For example, L1 and L2 are given as shown. The value of L1 is 1 Henry and value of L2 is 0.5 Henry. As we know, in series combination, L equivalent is the sum of two inductors L1 plus L2. Therefore, we can write L equivalent will be L1 plus L2, that is 1 Henry L1 and 0.5 Henry L2. The total inductance or the net inductance of this network is therefore 1.5 Henry. What about the example for the parallel network? Here the value of L1 is 1 Henry and value of L2 is 0.5 Henry. So as we recall from the formula, the L equivalent will be the reciprocal of the reciprocal of L1 plus reciprocal of L2. So we write 1 divided by 1 over 1 Henry, which is L1, plus 1 divided by 0.5 Henry, which is L2. And therefore, by plugging in those values, the L equivalent is equal to 1 over 1 Henry plus 2 Henry, that is 0.33 Henry. We continue talking about examples. There is a possibility that you come across such series parallel combination where L1 is connected as shown with a value of 1 Henry and L2 and L3 are connected as shown. So here we clearly see L2 and L3 are in shunt with each other, and this network is in series with L1. The values of all inductors are as shown. How to then calculate L equivalent for this network? So we know that L equivalent will be written as it is equal to L1 plus L2 in parallel with L3. So we can first calculate the L parallel. The L parallel, which is the parallel equivalent of L2 and L3, can be written as L parallel equal to 1 over 1 Henry, which is the value of L2, plus 1 over 0.5 Henry, which is the value of L3. Once you know the value of L parallel, you can see that L parallel is equal to 1 over 1 Henry plus 2 Henry. So total is 0.33 Henry. Now, therefore, L equivalent is L1 plus L parallel. So right over here, L1 plus parallel combination of L2 and L3. So L1 is 1 Henry plus L parallel is 0.33 Henry. Therefore, the equivalent value of inductor is 1.33 Henry. An exercise for you given here, you have to calculate L equivalent of this network. So what you see here, L1 and L2 are connected in parallel with each other with the value of each to be 1 Henry. And in series with this combination, you have another inductor that is L3, which has value of 2 Henry. Now, the question for you, calculate the equivalent value L of this network inductance value. And once you know the answer, write that in the comment section. So hope you found this short module quite useful about understanding about the series and parallel combination of inductors and how to calculate the equivalent or net inductance of the network. With this, stay tuned for more engaging content like this. Till then, wish you happy learning. If you like this module, please share it with us, others for a wider reach. Till then, see you again. Wish you happy learning.